All right, so we're getting into 11.2, which is graphing. Someone says something here. Let me go to the. Yep, it's 11.2. Yeah, I'm about to write that up there. So it's actually 11.2 for us. I had another section once again, wherein I had those notes set up for another class. And like I said before, math doesn't change, so we just run through those same problems. Actually, I'm going to start from scratch. I see 11.2 as graphing linear equations, but I want to make sure we're just clear with graphing, period. So that's why I'm starting at really 11.1. Just making sure we're okay with the Cartesian coordinate plane and the graphing system. So 11.1, 11.2 is what we're looking at right now. So first, the Cartesian coordinate plane is made up of your x-axis and y-axis. Your x-axis is your horizontal axis. Your y-axis is your vertical axis. Where they intersect is your origin. Coordinates of your origin is 0, 0. Everything to the right of your origin is positive. Everything to the left of your origin is negative. Everything above your origin is positive. Everything below your origin is negative. It's split up into four quadrants going. Let me get it out. Four quadrants going counterclockwise. So you got quadrant 1, 2, 3, and 4. Quadrant 1, you have to make two positive moves in order to get into it. Quadrant 2, you'll make a negative move and a positive move. Quadrant 3, two negative moves, and then quadrant 4 is positive and then negative. And you will graph by what we call ordered pairs. Called ordered pairs because the order matters. And it's always your X move first and then your Y move. Or in other words, you will move horizontally first, then vertically. Think about run, then jump. You walk, then go down in the elevator. Whatever helps you to remember that you always move your X first, then your Y. X comes before Y in the alphabet. All right, any questions so far? Okay. Somebody said something. It's 11.2. We're looking at 11.2. And it's right now we're just graphing linear equations. 11.2 graphing linear equations. All right. So let's look at graphing some of these. Just walking through stuff. Guess I kind of left them up there. I'll just write on top of it. Okay. So when we're looking at the 0.25, it's a positive 2 and positive 5. You start your origin and you go right 2 and then up 5. And so that's why 2, 5 is right here. Go to the right 2 and then up 5. That puts us in quadrant 1. All right. -1, -3. Start your origin. Go to the left 1, down 3. That puts us in quadrant 3. Two negative moves. Start at your origin. Go to the left 1, down 3. -4, 2. Once again, start at your origin. Go to the left 4, up 2. That puts us in quadrant 2. Go to the left 4 and then up 2. All right. Then 1, -5. Go to the right 1, down 5. And that's 1, -5, quadrant 4. Right 1, down 5. questions on either one of those 4 points? The next two, we have 3, 0. I will go to the right 3, and then nowhere for x. Nowhere for y. Don't go up and down, no, up or down for y. Go to the right 3, nowhere for y. That leaves my point to be on the x-axis. Then for 0, 3, I don't move left or right, x is 0, but then I go up 3. And that allows my point to stay on the y-axis. All right, questions? All right. So solutions for these equations, just an ordered pair is a solution of an equation if the equation is true after the ordered pair is plugged in or substituted in. So for this first example, 4x minus 3y equal to negative 2, if they give me the ordered pair, 1, 2, always remember your first component is x. First part of your coordinate is x. The second one is y. And then you will plug those in accordingly. 1 for x, 2 for y, so that'll be 4 times 1 minus 3 times 2 equal to negative 2. 4 times 1 is 4, 3 times 2 is 6, so 4 minus 6 is equal to negative 2. So that means 1, 2 is a solution for that equation. All right, make sure we're okay with that. All right, so there are infinitely many solutions to a linear equation. That's what that line represents when you graph it. Represent all of the points that are solutions to that equation. There's infinitely many points on this line, and any point that's on that line will represent a solution for your equation. So when we go to graph, that's what that graph represents. All right, so here I would just doing that process or that exercise again. We have y equal to 3x minus 5. We have pairs of 2, 3, and 3, 4 that we want to try to make sure that they are or are not solutions. So y equal to 3x minus 5 is our equation, and we want to try out 2, 3, and then 3, 4 to see if they work to be solutions for our equation. All right. So plugging in both ordered pairs, plugging in 3 for y, 2 for x. So that would be equal to 3 times 2 minus 5. 3 times 2 is 6, so 6 minus 5 is 1. So 2, 3 is not a solution. Plugging in 3, 4, that means 4 is y, 3 is x. 4 equal to 3 times 3 minus 5. 3 times 3 is 9. 9 minus 5 is 4. So it's equal to 4. So that means that is a solution for the equation. All right, make sure we are okay. Let me know if you have any questions. erase this stuff. I was scribbling on it. So there are three methods to graph your linear equations. We can create an XY chart. We can use our intercepts, or we can use our slopes. So I believe for us, both of these are 11.2, and then your slopes are 11.3. Yep, 11.2 and 11.3 is your slopes. Yep. So that's how we will do it. 11.2, we create XY chart, and our intercepts, discuss those two. And then 11.3 is our slopes. All right, so let's look at the first method. Erase this stuff so we can go through the process. All right, so we're going to create an XY chart. Let's look at the equation y equal to 2x plus 1. So you choose x values. Choose x values that you don't mind calculating with. Just remember that whatever you choose, you are going to have to calculate with that. So if you want to choose 150 and 1 million, that's fine. Just remember you're going to have to calculate that, and you're going to have to graph that. So I always choose easy values like -1, 0, and 1. All right. So you choose those values. Then you're going to find the corresponding y value by plugging it in for x. So we have y equal to 2x plus 1. So plug in the 1. 2 times -1 is -2. Then -2 plus 1 is -1. So it just so happens that when we plug in -1, we get out -1. Plug in 0. 2 times 0 is 0. 0 plus 1 is +1. So you plug in 0, you get out +1. Then plug in +1. 2 plus 1 is 3. So when you plug in +1, you get out 3. You get y equal to 3. So I'll give you a chance to write that down. Any questions? All right, so now graph those 3 points. -1, -1, 0, 1, and 1, 3. So we look at our points. -1, -1. Go to the left one, down 1, that's right here. 0, 1, you don't move anywhere for x, but you go up 1, which is right here on the y-axis. Then 1, 3, go to the right one, up 3. It's right here. And so we have an arrow, not an arrow, a line going through the 3 points. So we will have an arrow at the end of each line, just signifying that it goes on to infinity in this direction and to infinity in that direction. So that's why it doesn't matter what you choose, as long as you're able or willing to graph them. If I had a +20 that I plugged in for x, which would be way over here, it would go all the way up here and still connect with this line. Same thing with a -100, it would be all the way in that direction, but it will give me a point all the way down there that will still connect with my line. So like I said, whatever you choose, you're going to have to graph it. And if you're able to do so, then there's no problem. Questions on graphing? All right. So let's do another one. Let's say we have a fraction involved. So let's say we had negative 3/5 x plus 2. You want to be strategic in what you choose. You don't want to just choose any old thing because you don't want to have to graph decimals or fractions or whatever the case may be. So what we'll do is choose multiples of our denominator, whatever your denominator is. So in this case, that's 5. So we're talking multiples of 5. So when before I chose negative 1, 0, 1, I would choose negative 5, 0, and 5. So numbers that 5 can divide into evenly. So like I said right here, I can choose anything that 5 can divide into, 5, 10, 15, 20, 25, 30. Anything that 5 can divide into would be the best option here. So if I had 11 in my denominator, I would choose values that 11 can divide into. Negative 11, 0, negative 11, positive, 22, 33, 44. If there was a 7 down there, then I would choose values that 7 can divide into evenly. All right. What that would do for us is set us up in this way. I'll plug in negative 5. That's negative 3/5 times negative 5 plus 2. If I want to cancel out, I can, but if not, negative 3 times negative 5 is a positive 15 over 5. 15 divided by 5 is 3 plus 2, and the result would be 5. So it just so happens that when you plug in negative 5, in this case, you get out positive 5. Do the same thing for the other two. Plug in 0. Wait, look, I'll rewrite that. So that's negative 3/5 times 0 plus 2. 0 plus 2 is 2. So that'd be 2 for the next one. And then plugging in positive 5. It's negative 3 times 5 plus 2. So negative 3 plus 2 equal to negative 1. All right. So that should be a negative 1. So any questions on the plugging in before we go to look at the graph? All right, so graphing those 3 points, we have negative 5, 5. So I go to my origin, go to the left 5, up 5, which is right here. 0, 2, nowhere for x, but up 2. Then to the right 5, down 1. Leave that bad, then just a little further down. Then draw my line. All right, questions with creating the XY chart before we look at our intercepts? Any questions? So you get to choose your X values, plug them in, then find your corresponding Y value. All right. So the second method, your intercepts. Your x-intercept will be where the graph intercepts or crosses the x-axis. Your y-intercept will be where the graph crosses or intercepts the y-axis. So a characteristic of all x-intercepts is that y is always 0. Characteristic of all y-intercepts is that x is always 0. So we ran across those type of points before. Points that allow you to be on the x-axis or on the y-axis. If it's on the x-axis, that's because y is equal to 0. If it's on the y-axis, it's because x is equal to 0. Any questions? All right. So let's look at graphing using our intercepts. Here's some of this stuff. All right, so it doesn't matter which intercept you find first. I always tend to find my x-intercept first. But if we have 2x plus 3y equal to 12, I find my x-intercept, the first thing we have to look at. Let's see somebody asking the question. You're not sorry. You're not sorry, Miss Penton. I'm just messing. Let me see. Scroll up. Right here? All right, sounds good. Let's go to the next piece. All right, so let's graph using the intercept method, using those intercepts. So we have 2x plus 3y equal to 12. X-intercept, if we want to find your x-intercept first, let y be equal to 0. If that's the case, that means we're going to plug in y. I'll plug in 0 for y. So 2x plus 3 times 0. 3 times 0 is 0. And that leaves us with 2x equal to 12. Now I can solve for x by dividing both sides by 2. 2's cancel. That leaves me with x equal to 6. So my ordered pair would be 6, 0. Remember we plugged in 0 for y. Then finding your y-intercept. Remember your x-intercept and y-intercept are two different points. We're not going to put 6 together and then the result from the y-intercept together. Your x-intercept is 6, 0. Your y-intercept will be a separate point by itself. So we plug in 0 for x. 2 times 0 is 0. So that will leave me with 3y equal to 12. Then divide both sides by 3. 3 will cancel. Y is equal to 4. So my y-intercept would be 0, 4. Remember, x was 0. X always comes first. So it would be 0, 4. All right. Any questions so far? All right. So graph those 2 points. Go to your origin, go to the right 6, and then nowhere for y, that'll be 6, 0. And then nowhere for x but up 4 would be 0, 4. All right, questions before we do another one? As always, let me know if I'm scrolling up too fast. It's not a problem. All right, so we have 5x minus 4y equal to 20. If we're trying to find our x-intercept, first thing we'll do is let y be equal to 0. So you plug in 0 for y, and that'll be 5x minus 4 times 0 equal to 20. 4 times 0 is 0, leaving us with 5x equal to 20. Divide by 5, and that will be x equal to 4. So my ordered pair would be 4, 0. Next one, I'm going to let x be equal to 0 because I'm looking for my y-intercept. Plug in 0 for x, that's 5 times 0 minus 4y equal to 20. Then I'm left with negative 4y equal to 20, so don't leave off that negative right there. Sometimes people forget it. That's negative 4y equal to 20. Divide both sides by negative 4. Y is equal to negative 5, so my ordered pair would be 0, negative 5. All right, questions before we graph? All right, so graphing those 2 points. Go to the right 4, and nowhere for y, that's 4, 0. Then 0 for x, then down 5. So 0, negative 5. All right, questions on that before we look at our slopes? Let's see something. As a matter of fact, before I go there, All right, so horizontal lines, whenever I have my equation and it just says y equals, just y equal to a number, notice previous problems had x and y involved. If all you see is y, you should get a horizontal line. What this means is that y is always 5. So no matter what x is, y is always going to be 5. So if you go to set up XY chart, no calculation is needed. If you decide to go negative 1, 0, and 1, y is going to be 5 no matter what. So to graph that, you go to the left one, up 5. I said left one, I went right. So left one, up 5. 0 for x, up 5. And the right one, up 5. And I will have a horizontal line at 5. All right, question on your horizontal lines. All right, so vertical lines, x equal to a number. So if we have x equal to negative 2, that means x is always negative 2 no matter what y is. So y can be 1, 2, 3, doesn't matter. X is going to be negative 2 for each value. Excuse me. So go ahead and graph. Left 2, up 1, left 2, up 2, left 2, up 3. So we have a vertical line at negative 2. All right, questions before we look at our slopes. All right. So slopes, like I mentioned before, this is coming out of 11.3 for us. Slopes are going to be represented by M. So y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. It also represents rise over run. We will use that when we go to graph. So you can just hold on to that for a second. But rise over run is what we use to graph. We have to just make sure we stay consistent. If I use y2 first on top, then x2 needs to be used first on bottom. Or if I use y1 first on top, then x1 should be used first on bottom. And so the points or the numbers for x1 and y1, x2, y2, they just represent any 2 points on your line. So any 2 points on a line will give you a numerical value for the slope of the line. And so when we talk about the slope of a line, we're basically talking about the incline or the slant of the line, the steepness of the line. Like the slope of a mountain or the slope of a ramp. for Ruth. All right. All right. So we want to find the slope of the line, and they give us -2, -4 for one point, 3, -5 for the other. Go ahead and label which one you're calling point 1 and which one you're calling point 2. I decided to call the first point I saw point 1, which is x1, y1, second one, x2, y2. And make sure you plug in your values accordingly. So I'm going to do both ways to make sure that we see that you can go either way as long as you stay consistent with your plugging in. But normally when you're just doing it, you don't have to do both. So I'm going to do y2 minus y1 over x2 minus x1. So y2 is -5. Y1 is -4. So make sure you're careful. Make sure you don't lose a negative. There's a minus sign in the formula, and we're plugging in -4. So that should be -5 minus -4. Then you have x2, which is 3, over x1, which is -2. So you have a negative to a negative in both cases. So that just means that they're going to turn positive for you. This is what happened in this step. So we have -5 plus 4, 3 plus 2. That'll be a -1 over 5. All right. So going the other way, y1 minus y2 over x1 minus x2. So x1, excuse me, not x1, y1 is -4 minus y2, which is -5. Then we have x1, which is -2, minus x2, which is 3. Negative turns positive, so you have -4 plus 5, which is a +1, over -2, -3, which is a -5. And that would be a -1/5, which is the same value. So once again, as long as you stay consistent in your substitution, y2 first on top, x2 first on bottom, or y1 first on top, x1 first on bottom, you'll still get the same result. Any questions? All right. So let's do it one more time just to make sure we're good. We have 5, -6, and 8, 3. So first point, x1, y1, which is 5, -6, x2, y2 is 8, 3. So y2 is 3, y1 is -6. x2 is 8, x1 is 5. So we have 3 minus -6 over 8 minus 5. Once again, that negative to a negative turns positive, so 3 plus 6 is 9. 8 minus 5 is 3. 9 divided by 3 is 3. Any questions? are your basic behaviors of your slope. So if you follow your line or your graph from left to right, if it is going up, then your slope is positive. From left to right, if it's going down, your slope is negative. If you have a horizontal line, your slope is 0. If you have a vertical line, your slope is undefined. Any questions? Any questions? You got kicked out 4 times. Oh man. Sorry to hear that. I most definitely will be posting this video. I'll try to get it in there tonight if I can. All right. So next 2 relationships when it comes to the slopes. Parallel lines. I got 2 R's in there. It's not supposed to be 2 R's in there. Just one. So parallel lines and perpendicular lines. Parallel lines will never touch or cross. They have the same incline. So in other words, they have the same slope. Perpendicular lines create a 90-degree angle at the intersection. And they are negative reciprocals of each other. And you know, this little square here just represents 90 degrees. You never assume that you have 90 degrees. So you either have to have a symbol or be told that it is 90 degrees. So as soon as everybody's copied, I will let you know what it means specifically by having negative reciprocals. So parallel lines have to have the same slope. Perpendicular lines will have to have slopes that are negative reciprocals of each other. So if you're just talking about regular, just reciprocals, that means you flip the fraction. So 4/5 and 5/5 are reciprocals of each other. Negative 10 over 7 and negative 7 over 10 are reciprocals. And 8 and 1 over 8 are reciprocals of each other. All you're doing is flipping the fractions. Whatever the signs are, they stay the same. Reciprocals, all you're doing is flipping the fractions. Now, negative reciprocals, negative mathematically means opposite. So negative reciprocals means you flip the fraction and use the opposite sign. So if you have 4/5, the negative reciprocal of 4/5 will be negative 5/4. If you have negative 10 over 7, the negative reciprocal will be 7 over 10. And then for 8, the negative reciprocal would be negative 1 over 8. All right. Questions? Any questions? right. So here, if I just wanted to just re-emphasizing the relationship of your slopes to parallel and perpendicular lines. So give the slope of the line that's parallel, and then give the slope of the line that's perpendicular to the given slope. So just making sure we're clear. So if I have the original slope to be 3/5, and I want the line that has slope that's parallel to 3/5, remember parallel lines will have the same slope. So that would be 3/5 as well. Parallel lines will have the same slope. Now, if I want the slope of a line that's perpendicular to that, I will use the opposite sign and then flip the fraction. So it would be -5/3. All right. You want a line that's parallel, you use the same slope. Perpendicular, you use opposite sign and you flip the fraction. So another example, if my original slope is -11/9 and I want a slope that's parallel, my slope would still be 11/9, -11/9. Perpendicular, it would be +9/11. Questions? Any questions? Oh, I did another one too. So I did one more. 1/7. Parallel will be 1/7. Perpendicular, you flip that, use the opposite sign, be -7/1, which is -7. So questions on the relationships? Any questions? Parallel, use the same sign. I mean, not the same sign, the same number. So that would be the same sign as well. But then perpendicular, you will use opposite signs and flip the fraction. Hold on, I think we are good. I'm looking at. Let me check one thing before I do this. Hold on real quick. Because we may not have to graph using our slopes. So I want to make sure that before we close out. Okay. So we don't have to graph using our slopes. That's actually in 11.4. Yep, slope intercept formula line. Yep, so you are held responsible for 11.2, 11.3, and so what we'll do is 11.6 on next class. Multiplying, dividing expressions with common basis. And go from there. So questions on anything before we close out today? Okay, cool. All right. So yeah, so that's it. That's 11.2, 11.3. Like I said, we'll do 11.6. And I don't know if I'm gonna do any more than 11.6 next class. I'll try not to, because that's the only section left in 11.6. It was 11.2, 11.2, 11.2, 11.3, 11.6, and then it's chapter 13. So I may hold off and do chapter 13 next week. Start chapter 13 next week, but we'll see. Uh, you meant sorry? It's all good. It's all good. So outside of that, if you have questions, make sure you bring them to class. I mean, I'll answer them. If not, always feel free to shoot me that email. And I'll answer them there. Or if you need to set up a session, I know somebody had asked me before about setting up a session, Zoom session, like an office hour. Then they never got back with me as far as what times were good for them. So always feel free, let me know. We can do that. Okay. Outside of that, you guys have a great weekend. Not weekend. Have a great day. Be safe, and I will see you on next class. Email me. Shoot me an email. Shoot me an email if you want to set up a session, and then we go from there. All right. Everybody take care.